Hello guys, today we're gonna interview my flatmate. He doesn't know that he's gonna be interviewed today. So, hello, do you know that you're gonna be interviewed today?
No,
So, what's your name?
I'm Che.
Where do you work, Che?
Huh?
Where do you work at?
Cloudera.
Cool, so now we're gonna test how good Cloudera employees are at interviewing skills. This is the view Che is gonna be enjoying while solving the algorithmic problems today. So, take the laptop and start coding.
You're so mean.
No, I'm not. What are you even talking about?
Even a binary tree and a sum determine if the tree has a root to leaf path such that adding up the values along the path equals to the given sum.
So, did you understand the question?
Not really. So
Maybe it was drawing a tree on a whiteboard, or why did I even take the whiteboard here?
Yeah, can you show me some example of this?
Yeah, sure. So, let's say you have the following tree. 5, then it has a left node 3, and this guy is 4. This guy is having, let's say, 2. And your goal is to find a number, let's say, 9, then you're gonna go this way. If your goal is to find a number, let's say 6, there is no way to the leaf.
I see.
If you're given number 8, it's also impossible because even though this path sums up to 8, this is not the leaf, so it's wrong. Therefore, if we find a path, like let's say we need to find 10, then we can go this way.
So
That's
the definition of the summation is from the root sum up to the leaf.
Yeah,
Okay.
exactly.
I see. So what if there is no answer at all? What should I? So the return is to
You
return
need
either
to return
yes
whether
or no.
there is a path or no. So,
Okay.
yeah.
As long as there's what if there are multiple paths that sum up?
You need only
Still
to say
return
whether there is
yes.
at least one, so it's either true or false. And so
I see.
cool.
I think now I understand the question.
Now, get down to code and write it.
So I guess we'll have to do some like tree traversal, right?
Right.
Yeah.
Right.
So I haven't written this for a while.
So you could see that the tree only has left and right.
Yeah.
So there is.
So let's do just any kind of traversal, and when we hit the root, we try to accumulate the value, and as long as we hit the leaf, and then we check if that is equals to our summation. Actually, actually the other way to think of it is just we can have initially we have a sum, right?
Right.
And once we get down to a level, we just minus that summation until we hit a leaf. Is that 0? Then that's what we want, and we just return, right?
That's a good point. I
think?
love your approach. So take the laptop and do it. And try to think out loud as how would you perform in the real interview. Do it.
Okay. I haven't written C++. So okay. Initially there is a sum here, and I guess I want to check the left and the right.
What is the definition of a leaf? Like, what is leaf?
Oh yeah, the definition of the leaf is when there is no child at all.
Right. Could
So
you
that's
write a
determinate-
helper function which would tell you whether the given vertex is a leaf or no?
Sure. So that's the helper function. You want, right? Given a tree node,
Right.
I'm going to return you if it's called is leaf, right?
Yeah.
Root dot. I'm not sure. Like if that's already a null, what should I return?
If it's already null, then probably
Is it
you
leaf
should
or not?
return false, I think.
Okay.
Or what do you think? Like, if it's not vertex, like the leaf is a vertex, and if something is not vertex,
Yeah, then it should probably no. Okay. So if first check this, right? If what is the syntax? Is that right? C++.
looks like you're so much in Go.
Oh yeah. Now or
Root-
no?
null. Caps. Yeah, caps. Totally caps.
Yeah. Thank you.
And
You're so kind. Okay. Return false. That's the syntax.
yeah, like
This.
this. And remove this return.
Oh yeah. Now I remember. Oh yeah. Okay. And right now we're going to check the. You're right. Yeah, C++. Check the left and the right, right?
Mhm.
So if they are both null, then I'll return true.
Oh,
Is it-
probably you wanted here to have an equal sign, right?
Hmm?
If you want to have an equal sign here, right?
Oh yeah, you're right. Thank
Cool.
you.
So now we need to check what is the value of the left and the right.
Yeah.
No.
How do I write it?
Right.
And
Ampersand.
oh yeah, and sorry. Oh, yeah, so bad. Double and
I think. Well, yeah.
this is bull.
yeah,
This is
yeah. You can use one, but it's fine to use both.
okay. So
Cool.
okay.
Right.
Yeah, you're right. It's all you're. Oh,
Oops.
I have a good habit to save the code.
All right. So you know when you hit the leaf.
Yeah,
So let's
That's the
get
tuning.
back to the
Okay.
function.
yeah. So that's. Let's start with the helper function, I think.
Mm-hmm.
Or can we just directly use this function? I think?
Like, elaborate on what kind of helper function would you like to have?
No, I don't think we need a helper function.
All right.
Yeah, just do this recursively. Just call has like if I hit a node, I'm going to check the return from the left and the return from the right.
Right.
If either of it gave me a true,
Right.
that means I already found the answer.
Right. That's
Right.
correct.
Yeah.
So just check left sun,
Yeah.
right sun, and
So return from the left would be has ooh.
oh, all right. Yeah. I mean, do you want to write a function or is it a variable?
It's just calling myself, I think.
All right. Oh shit! I'm so blind. You're right.
What do you mean?
I didn't notice that you were calling the function self. Sorry.
Yeah.
Never mind.
So my idea is like if currently, I mean my goal is to have a 0, right?
right.
If that's 0, then and I'm at the leaf,
Yes.
I'm the leaf node, then
Mhm.
I'm going to return true, right? That's our base condition.
Right.
So if root is leaf, right? This is
Yep.
the helper function.
Yes.
And the sum mentioned, and oh yeah, and our sum
Equals.
goes to 0,
Yep.
then we're going to return true.
Cool.
Right. So suppose in the base case, like we only have one node in this tree,
Right.
right? And we want the summation to be 5. Then actually we want to return true. So in that case, we need to minus the value of this node first.
Right.
Right.
That's correct.
That's correct. Okay. So I think first thing we have to check is if the root is even just a null.
Right. That's a good observation. So
Yeah,
check
so-
it first.
So check it first. If that's null, and what should we do? Just return
False. or true? I think false is fine.
False, right? It's nothing to do.
Yeah.
Okay. So that would prevent us from accessing the null pointer. Huh? What else? What happened?
Return.
Huh?
Return here.
Oh yeah, return. Yeah. Okay. Oh, I'll save again. Okay. So if that is
So
now
everyone knows what is on my desktop right now.
Okay.
So
if that is not known, that means that it's a valid node. I'm going to subtract the value of the node.
right.
Right. So
Sum minus equals root like this, the arrow.
yeah, the root is a pointer. Okay, good point.
Cool.
Oh, so those are integers. So
I think you shouldn't worry about this. Just forget about overflows.
yeah, we are doing the minus, right? So
Right, but like, don't worry about this in terms of this question.
you're so kind. Okay. Okay, so that's our current dimension. So now we are going to check, right?
Yeah.
If this is already a leaf, it's leaf. Okay, leaf, and the summation is 0 and return true. That's the condition. That's the using the example. I have like only one node in the in the tree. So in this case, I'll just directly return.
Yeah, this is a good point. Cool.
Right. So if okay, so now we're considering like this real case here.
Right.
Like I'm going to see recursively checking if I left the return of my left node return true or the right side of the return a true. Either way, just
Right.
give me
That's
give me a
exactly
true.
what we need to do.
Yeah. So that'll become a simple recursive function call, I think.
Yep.
So we are going to just check from the left. What is it called? Has value on the left subtree or has passed on
I think
the
you
left
could just
subtree?
inline it in return.
Okay, let's just do it inline. Okay. One liner. Return
Yeah.
has passed on root left.
Yeah.
So-
here you go. Looks like you've
And-
been coded in C++.
Sorry, or
Yep. Cool.
steps on. On the right. There we go.
Done. Click submit.
Click submit.
All right, you ready to click submit? Click it.
You think it's bug free?
I don't know. Let's just see.
No, compile error.
Compile error. What does it say?
Semicolon.
All right. Let's see. Cool. So guys from Cloudera can solve the problems in the languages they haven't been using for maybe a few years. So it's kind of really cool. Can you guys solve this problem in iterative way? I don't know who's gonna be the next guest. Maybe there will not be any videos at all, or maybe there are gonna be plenty of them, but feel free to comment, put like, and yeah. See you in the next videos.
We don't talk anymore. We don't talk anymore. We don't talk anymore.